Today, I'm sharing my research on how Internet of Things technologies were deployed in Singapore to combat COVID-19, which is an airborne viral disease that challenged densely populated cities worldwide. IoT refers to physical objects with sensors and processing abilities that connect to network and exchange data. During the pandemic, these technologies became critical systems that could monitor the physical world in real time, helping authorities identify cases and guide decision making. Singapore deployed sophisticated IoT-based thermal imaging systems at high-traffic locations such as Changi Airport, shopping malls, and schools. GovTech sensors and IoT team developed an automated temperature scanner that could screen individuals without any human intervention, solving both the thermometer shortage issue and reducing infection risk for staff. The temperature taker used a non-contact infrared thermometer to take temperature, camera technology to detect faces, edge computing to process and display temperature, and finally network connectivity to send temperature data on the internet. This eventually evolved into Spoton, which is an advanced system that could check temperatures up to 10 people simultaneously. By combining infrared camera technology for thermal readings, RGB depth camera technology for face detection and mask checking, on-device AI algorithm for simultaneous monitoring, and finally cloud connectivity to alert operators when high temperatures were detected. The effectiveness of this solution was impressive as Spoton maintained accuracy of zero point 0.3 to zero point 0.5 degrees Celsius, validated by Singapore's Natural Meteorology Centre, and was successfully deployed at large events with thousands of attendees. As IoT implementations, this system incorporated all key elements of IoT, which is using sensors to collect data, edge computing for on-device analysis, autonomous operation, and finally network connectivity for alerts. Now let us look at the second case study, Trace Together ecosystem. The Trace Together ecosystem combines several IoT components, such as the Trace Together mobile app and physical token, the safe entry check-in system and gateway, and finally the COVID-19 cloud management system. Together, these create a decentralized Bluetooth mesh network where mobile devices and tokens function as edge computing nodes that continuously exchange proximity data, which was then analyzed in the cloud management system. Now let us look at the implementation. Rather than tracking location data through GPS, which will perform poorly indoors and raise privacy concerns, GovTech brilliantly shifted to tracking who instead of where using Bluetooth low energy signals. When TraceTogether is installed, the backend generates a unique user ID paired with the user's phone number. The app also generates temporary ID for device communication, with data packet containing the user ID, creation time, and expiration time, all of which are encrypted before transmission. Using Bluetooth's generic access profile, devices alternate between the peripheral row and the central row. When devices detect each other, they exchange encounter messages containing temporary ID and additional data. Central devices can also measure the received signal strength indicator (RSSI) of incoming signals, which help to estimate physical distance between users. Devices continuously switch between these two rows to ensure robust two-way information exchange, which is a critical feature for accurate contact tracing. When somebody tests positive for COVID, they'll upload their encounter history to the COVID management system. The system will decrypt the temporary ID to extract unique user IDs, validate the authenticity of each encounter message, and use cloud-based algorithms to identify close contacts based on the duration of exposure and proximity estimation. This automated process allows health authorities to quickly identify and contact individuals who have been exposed to the virus. To ensure inclusivity, especially for elderly citizens and children without smartphones, Singapore introduced the Trace Together token, which is a hardware implementation of the same technology. These tokens contain a Bluetooth 5 certified wireless microprocessor, a real-time embedded clock, and a 64 MB flash memory. The tokens store up to 30 encounter messages every 5 minutes, creating a comprehensive contact history while only requiring the user to bring the token around locations. Complementing TraceTogether was SafeEntry, Singapore's national digital check-in system for public venues. It worked through QR code scanning, where users can scan venue-specific codes with their phone, or SafeEntry gateway boxes, which are hardware devices that automatically detect nearby TraceTogether apps and tokens. From an IoT perspective, phones function as edge computing nodes, processing check-in data, while gateway boxes acted as Bluetooth sensors constantly scanning for nearby devices. Upon detection, these gateways would decrypt signals, add location data, re-encrypt, and transmit the information back to the cloud. This creates a comprehensive system tracking both who you were near using TraceTogether and which locations you visited using SafeEntry. At the center of this ecosystem was the COVID-19 management system, which was a cloud-based data aggregation and analytics platform that processed data from millions of IoT endpoints, identified and verified COVID-19 cases, traced contacts through encrypted IDs, generated real-time dashboards and heat maps, and identified potential COVID-19 hotspots and clusters. How effective is this system? According to Ministry of Health, TraceTogether identified approximately 25,000 close contacts of confirmed case, with 160 of these contacts later testing positive for COVID. By October 2020, 2.7 million Singaporeans have downloaded the TraceTogether app, and almost 560,000 had collected tokens, creating a massive IoT network of interconnected devices.